This is Naga Lakshmi Devi, Assistant Professor, Department of Freshman Engineering, IARE, Hyderabad, Telangana. Now the continuous random variable problems. The first problem is the probability density function of f of x of a continuous random variable is given by the function f of x equal to 1 by 2 sin x. The intervals are 0 less than x less than pi and another remaining all are zeros. If 0 and pi in between value is, the function is 1 by 2 sin x and the remaining all are zeros. Here we are finding the mean, median, mean deviation, mode of the distribution and also find the probability between 0, pi by 2. This is the given conditions. Now, the first solution. Given function f of x equal to, in between 0 pi, the function is 1 by 2 sin x, otherwise sin x by 2. Remaining all are zeros. If the mean mu equal to, here mean mu equal to integral minus infinity to infinity x into f of x dx. But the given function is lies between 0 and pi. Now this can be split into some subparts. Integral minus infinity to 0 x into f of x dx plus integral 0 to pi x into f of x dx plus integral pi to infinity x f of x dx. Here we know the 0 to pi has the function is sin x by 2. That remaining all are zeros. Why? Because the function is like this. If the integral is minus infinity to infinity, here they are asking 0 to pi. 0 to pi has the function is sin x by 2. The remaining all are zeros. That means pi to infinity is 0 and 0 to this infinity minus infinity value is also 0. That's why here we are choosing 0 to pi term and the remaining all are zeros. That's why we are considering integral minus infinity to 0 is the 0 term and finally integral pi to infinity term as 0. What about remaining? That is 0 to pi x f of x dx is a function. X is as it is x and f of x is nothing but 1 by 2 sin x by 2. I am substituting that. Now, the x into 1 by 2 into integral 0 to pi x sin x dx. The value is pi by 2. Finally, we get the value is pi by 2. Applying the x into sin x formula, we get the value equal to pi by 2. Now, the upper limit is pi and lower limit is 0. Applying that one, we get the answer is pi by 2. Next, here they are asking mean, median, mean deviation, mode and extra. Now first of all mean is completed. What about median? Median means here the conditions are, for example, we are choosing A to B, the middle value equal to M. Here M is the A to M is the one of the off part and M to B is the end of part. The total equal to 1 by 2. Here total is equal to 1. First part is 1 by 2 and another part is 1 by 2. Total is 1. Here integral A to B f of x dx is equal to 1. I am splitting into subparts. That is subpart is in between middle value is M. I am choosing M is the median. That is M into f of x dx plus M into B f of x dx equal to 1. That means 1 by 2 plus 1 by 2 is equal to 1. In between, here I am choosing integral A to M f of x dx is equal to integral M to B f of x dx equal to 1 by 2. This part is 1 by 2 and this part is 1 by 2. That's why I am choosing in between is equal to. Then I am taking only one off part. That means either this part or this part. First of all, I am considering this part. That is integral A to M 1 by 2 integral A to M f of x dx equal to 1 by 2. Here f of x dx is nothing but 1 by 2 sin x dx. Integral of sin x, here integral A to M, integral A to M 1 by 2 is a constant. 1 by 2 sin x dx equal to sin x integral is minus cos x. Minus cos x integral A to M that equal to we are applying the limits, we get the answer. Upper limit is cos M minus plus cos Gu. that equal to 1. Here 1 by 2 I am applying in both sides. 1 by 2 get cancelled. Remaining part is this one. Here cos m equal to 0. Why we are considering means cos 0 value is 1. 1 minus 1 it is 0. Cos m value equal to 0. Then cos m 0 means cos 90. Is cos 90 value equal to 0. I am substituting that value. We get cos m equal to cos 90. That equal to m equal to 90. 90 is nothing but 1 by pi by 2. Now, here why I am considering a equal to 0 means, here earlier they are given 0 to pi. A value equal to 0 and b value equal to pi. That's why I am considering here it is cos minus cos x m2. M is pi, pi. Here m equal to m. In between value is pi. B value is pi and 0. That's why I am considering minus cos m minus into minus upper limit minus lower limit. It is minus into minus plus cos 0. That is this one. 1 by 2 we get cancelled. We get only 1. That's why it is equal to 1. Again, minus cos m plus cos 0 value equal to, cos 0 value is 1. 1 minus 1 it is 0. That means minus cos m equal to 0. That means cos m equal to 0. Cos 90 value 0. That's why I am considering cos m equal to cos 90. Then m equal to 90. That equal to m equal to pi by 2. Pi by 2. That's all. Here 0 is nothing but upper limit minus lower limit. Here 0, a equal to 0. Yeah, I am choosing here a equal to 0. Why? Because the given condition is 0 to pi. Here one part is pi by 2 means the remaining half part is also pi by 2. Now here one part, this part is pi by 2. Similarly, we are completing this part also. We get another pi by 2. Pi by 2 plus pi by 2 is nothing but pi. Now b value equal to pi, then it is satisfied. The condition is satisfied. 0 to pi. The condition is satisfied. Next one. Mode. Mode is the value of f of x. Mode is the value of x for which f of x is always maximum. Here mode meaning means the given function f of x is always maximum. Mode is nothing but derivative of f of x is equal to 0. The derivative of f of x is equal to 0. Always here f dash of x equal to 0. The given function, the f of x, we are derivating that part that is equal to 0. That is the mode definition. Here we are considering f of x equal to sin x by 2. Now what about the f dash of x? That is cos, sin x derivative is cos x by 2. Then that is the derivative of f dash of x. Now the formula definition of the mode is f dash of x equal to 0. I am applying that one. F dash of x equal to 0 means it is 0 equal to cos x by 2. That means cos x equal to 0. Again cos x equal to cos 0 means cos 90 I am applying considering x equal to 90. That means x equal to pi by 2. That's all. Yeah, the mode is nothing but f dash of x equal to 0. The derivative of the given function is always 0 and the given f of x is always maximum. Finally, find the value of x means here x value equal to pi by 2. We get the x value pi by 2 by using mode definition, f dash of x equal to 0 condition, and it is maximum also. That is the mode. Next one, mean deviation. Mean deviation about mean deviation equal to, the formula is integral minus infinity to infinity x minus mu into f of x dx. Here mean mu equal to pi by 2. In first condition it is mean, we are finding that one, that mean mu equal to pi by 2. Mean mu equal to pi by 2. We are finding that one. Finally we get the mu equal to 1 by 2. I am substituting pi by 2. I am substituting that in the given mean deviation formula. Integral minus infinity to infinity x minus mu, and that is nothing but pi by 2 f of x dx. Here what about f of x means sin x by 2. Integral minus infinity to infinity x minus pi by 2 sin x by 2 dx. Now applying the median values. Here the given condition is 0 to pi. That's why I am converting to 0 to pi x minus pi by 2 sin x by 2 dx. I am substituting the each and every term here. That means integral 0 to pi x 1 by 2 common with the 1 by 2 x into sin x dx minus pi by 2 is a constant. Already sin x 2 is there over this is pi by 4 integral 0 to pi sin x dx. Now substituting total we get the answer equal to 0. Now mean deviation is the value is 0. Now next. And finally fourth one is integral 0 f of 0 less than x less than pi by 2 equal to, in the given condition is like this. Then simply we are solving the integral 0 to pi by 2 is the given function, given values. The function f of x equal to 1 by 2 sin x dx. 1 by 2 is the constant, integral 0 to pi by 2 sin x dx. That equal to 1 by 2 sin x integral is minus cos x 0 to pi by 2. The final value equal to, we get 1 by 2. Applying minus cos pi by 2 is 0. Minus into minus plus cos 0. Cos 0 value is 1 by 2. 1. Then it is 1 by 2. That means here 1 by 2 upper limit minus cos pi by 2. Cos pi by 2 value is 0. Upper limit minus lower limit. Minus lower limit means minus cos 0 into minus. That is plus. That is plus cos 0. That value equal to 1. 1 by 2 into 1. That equal to 1 by 2. That is the answer. Here integral 0 to f of 0 to x less than pi by 2. The value equal to pi by 2. 1 by 2. That value equal to 1 by 2. That is the total problem. Now here also simplification we get the answer equal to 0. Now this is the completed this problem. First of all we are finding the mean, median, mean deviation, mode of the distribution, and finally the probability between 0 comma pi by 2. We are finding all these things. Next one. The diameter of an electric cable is assumed to be continuous random variable with the probability density function. Here they are considering electric cable. The continuous by electric cable complete diameter they are given. The given data is that one. Continuous random variable with the probability density function. You are asking the probability density function. That means continuous random variable problem. And this is f of x equal to the given function f of x equal to 6x into 1 minus x. The limits are 0 to 1. And remaining all are zeros. That means the limits 0 to 1 has 6x into 1 minus x. The remaining all are zeros. Otherwise remaining all are zeros means remaining all are zeros. Justify and find the mean and variance of the distribution. Find and mean and variance. Simply they are asking mean and variance. Here we are choosing, we know the integral minus infinity to infinity f of x dx equal to 1. Okay, what is the mean formula? Integral minus infinity to infinity x into f of x dx equal to f of x dx. I am splitting into subparts. Subparts, that is integral minus infinity to 0 x f of x dx plus 0 to 1 x f of x dx plus 1 to infinity x f of x dx. Here this term is completely 0 and this is also completely 0. The remaining only integral 0 to 1 x f of x dx only. That equal to integral 0 to 1. Here what is the f of x? Here the x is as it is. Here what is the f of x? F of x is nothing but 6x into 1 minus x. That is 6x into 1 minus x into dx. That equal to integral 0 to 1 6 into x square of 1 minus x dx. That equal to integral 6 is constant. We are eliminating outside. That is 0 to 1 x square minus x square dx minus 6 into integral 0 to 1 6x square into x, that is x cube dx. 6 into x cube by 3. The integral of x square is x cube by 3. Integral 0 to 1 minus 6 into x cube, the integral part is x power 4 by 4. Integral 0 to 1. That means here it is 6 into 1 by upper limit 1 by x cube. The 1 means 1 by 3. Upper limit minus lower limit. The lower limit 0, 0. Minus 6 into 1 by 4. The total we get 1 by 2. That means we are using here, that means 6 into 1 by 3 means it is, we get finally 2 minus 3 times and 2. That means 3 by 2. 3 by 2. That is 4 minus 3 by 2. That equal to 1 by 2. Then mean equal to 1 by 2. Then mean equal to 1 by 2. Here the mean equal to 1 by 2. Completed. What about variance? Variance is E of x square minus E of x whole square. Otherwise, we are considering x minus mu whole square into f of x dx. Integral minus infinity to infinity x minus mu f of x dx. We are considering that is also variance. I am choosing second one. Integral minus infinity to infinity x minus mu whole square f of x dx. I am choosing here the variance. That is integral minus infinity to infinity x minus mu whole square into f of x dx is the variance. Integral minus infinity to infinity x minus, what about mu? Mu means mean. Mean here it is 1 by 2. 1 by 2 whole square. F of x means here it is 6x into 1 minus x dx. I am again splitting into subparts. Integral minus infinity to 0 plus 0 to 1 plus 1 to infinity. This part becomes 0 and this part becomes 0. We get only this part. That is integral 0 to 1 x into 1 minus 2 1 by 2 whole square 6x into 1 minus x dx. Now again integral 0 to 1. Now applying the complete equation a minus b whole square, a square minus 2ab plus b square, that is x square plus 1 by 4 minus 2 into 2 get cancelled. 2 by 2 is we get cancelled. We only get x into 6x into 1 minus x dx. We are solving this total equation. We get the variance equal to 1 by 20. 1 by 20. Here 6 is a constant. We are eliminating that one. X into 1 minus x, that is x minus x square. Multiply that total term in this here. We get the variance, the value equal to 1 by 20. This is the practice problem of this one. The diameter of the electric cable is assumed to be continuous randomable with the probability density function is equal to this one. And justify the mean and variance. The mean equal to, we get 1 by 2. The mean formula equal to integral minus infinity to infinity x f of x dx. And variance formula is integral minus infinity to infinity x minus mu whole square f of x dx. Next, third one. Next problem. The length of time. We are considering in time in minutes. That a certain lady speaks on the telephone is found to be random phenomenon with a probability function specified by the function. Here the given function is f of x equal to a into e power minus x by 5 for x greater than 0. Remaining all are zeros. Here the given function 0 to minus infinity to infinity, 0 and above terms are a into e power minus x by 5 and remaining all these terms are 0. Find the value of a. Take that makes f of x a probability density function. First one, we are choosing the f of x is a probability density function. That means equal to 1. Find the value of a. Simply we get the value of a by using probability density function. First one is okay. What about next one? What is the probability that the number of minutes that she will take over the phone is more than 10 minutes? If the lady is calling the telephone conversation, the conversation more than 10 minutes, they are asking the total phenomena of the problem. random phenomenon of the problem. About 10 minutes. Okay, these two are the conditions. Here I'm choosing first one. The condition is integral minus infinity to infinity. That is a probability density function. That means f of x dx equal to 1. I am splitting into two parts. That equal to integral minus infinity to 0 f of x dx plus 0 to infinity f of x dx equal to 1. Here this part is 0. I am taking only this part. Integral 0 to infinity f of x dx equal to 1. Integral 0 to infinity. What about that one? 0 and above term as a into e power minus x by 5 into dx is equal to 1. That means a into integral 0 to infinity e power minus x by 5 dx is equal to 1. That means a into here the integral of e power minus x by 5. E power minus x value is e power minus x by minus 1. Similarly, here applying that also. E power minus x by 5 that equal to minus 1 by 5. The upper limit equal, the lower limit is 0 and upper limit is infinity that equal to 1. Then a into 1 by minus 1 by 5 that is minus 5. That is minus 5. Upper limit is infinity. The total is 0. Upper limit minus lower limit, then the total is 0. Upper limit minus infinity, that is 0. 0. Upper limit minus lower limit, it is minus e power minus 0, that is 1. That is total 1 equal to 1. Then a into 5 equal to 1. That equal to a equal to 1 by 5. That we get the value of this one. Find the value of a means the value of a equal to 1 by using probability density function. Here e power minus infinity value is 0. Upper limit minus lower limit, the lower limit is 0. E power minus 0, e power 0, that is nothing but 1. Then it is 1. Minus 5. 1 by 5 is enter into the numerator, that is minus 5. Minus 5 into minus 1, we get 5. A into 5 equal to 1, then a equal to 1 by 5. That's all. This is the first part calculation. How to find a? For example, they are given either c or k, something, any other constants. Find the constant like this by using probability density function. If they are asking probability mass function, that is in distribution, that is discrete random variable problem. Already we can see in earlier, that is discrete random variable problem. Here they are asking mention specifically probability density function. The density function is integral minus infinity to infinity f of x dx equal to 1. Now the first part is completed. What about next one? Here the given condition is, what is the probability that the number of minutes that she will take over the phone is more than 10 minutes. More than 10 minutes. They are asking greater than 10. Now I am considering same condition, integral minus infinity to infinity f of x dx equal to 1. More than 10 they are asking. I am choosing integral minus infinity to 10 f of x dx plus 10 to infinity f of x dx. Then I am choosing integral 10 to infinity f of x dx. Here what about the f of x dx? 10 to infinity. Here f of x means a equal to 1 by 5. 1 by 5 into e power minus x by 5 into dx. Now substitutions. Integral 1 by 5 e power minus x by 5. The integral of e power minus x by 5 is e power minus x by 5 by minus 1 by 5. 10 to infinity. Then 1 by 5 into minus 5. 5 get cancelled. E power infinity, it is 0. E power minus 10. E power 10 by 5. E power, okay. I am substituting, that is, it is e power infinity minus upper limit minus lower limit. That is e power minus 10 by 5. That means here it is first, this term is 0. Then 0 in minus e power minus 2. Then e power minus 2. That can be written as 1 by e square. 1 by e square. Here, finally we get the 1 by e square. Here, e value is 1.14 or something. We are substituting that one. Otherwise, you can stop here and so no problem. More than 10 minutes. See, the phone, she will take over the phone is more than 10 minutes. That value is 1 by e square. The probability value is 1 by e square. Oh, this is the problem. Directly we are considering this also, no problem, not an issue. Directly we are considering integral 10 to infinity f of x dx also we can consider. That is the better. Okay, directly we are choosing that one. Why? Because what is the probability that the number of minutes that she takes, directly they are considering. That's why I am considering integral 10 to infinity f of x dx. Next, the probability density f of x of a continuous random variable is given by f of x equal to c into e power minus e power mod x. Here e power minus mod x is a even function. Okay. Now the limits are minus infinity less than x less than infinity. Here find c and find the mean and variance of the distribution. Asking extra mean and variance and find c also. Distribution. Also find the probability that the variate lies between 0 and 4. Here extra they are asking 0 and 4 also. Lies between 0 and 4 also. In earlier we are finding a, like that here we are finding the c also. Integral minus infinity to infinity f of x dx is equal to 1. Integral minus infinity to infinity. What about f of x here? It is c into e power minus mod x dx. Here c is a constant, c into integral minus infinity to infinity e power minus mod x dx. Here we know one formula is there, integral minus infinity to infinity f of x dx. F of x dx is equal to 0 if the given function f of x is odd. F of x is odd. If integral 2 into integral 0 to infinity f of x dx, if the given function f of x is even. Here exponential of minus mod x is a even function. That's why I am considering c into integral 2 into integral 0 to infinity f of x dx. That equal to 2 into c into integral equal to 1. Okay, I am leaving that part. Okay, by mistake. That implies integral 0 to infinity f of x dx is equal to 1. Simply, I am considering 2 into c into integral 0 to infinity e power mod x, that means e power minus x dx is equal to 1. Then 2 into c into upper limit minus lower limit, I am applying that, it is minus 1. Integral 0 to infinity is equal to 1. 2c into upper limit equal to minus, this is minus, we are eliminating outside, we are getting the outside in minus, upper limit is minus 1, minus, it is minus 1. E power minus infinity value is 0. Upper limit completed. What about lower limit? Minus lower limit, upper limit minus lower limit. E power minus 0, that is 1. Minus 1. Then it is minus 1 equal to 1. That is 2c equal to 1. Therefore, c equal to 1 by 2. Then c equal to 1 by 2. We get the first one c value. We get that is 1 by 2. Next, similarly, we are finding the mean also. Mean is nothing but integral minus infinity to infinity x into f of x. X into f of x. Here, luckily, the mean value is 0. You can see that one also. Then after variance, then after the limits lies between 0 and 4. Totally here they are asking one c value, mean value, variance and extra variate also. We are calculating that also. Now, what about mean? Mean means integral minus infinity to infinity x f of x dx. Here integral minus infinity to infinity x as it is. F of x means c into e power mod x. C equal to 1 by 2. 1 by 2 into e power minus mod x dx. Okay, here x is one condition is there. Odd function is 0 and even is integral, again I am substituting that also. Integral minus infinity to infinity f of x dx equal to 0 if it is the function f of x is odd. 2 into integral 0 to infinity, the function f of x is The function f of x is even. That means here e power minus mod x is a even function. X is a odd function. Odd into even. Odd function. The odd function value is 0. The odd function value is 0. Directly we are considering it is 0. Luckily we get like this. Okay. If any doubts are there? No. Then what about variance? Here why we are choosing 0 means why we are considering 0? Here x is odd function. E power minus mod x is a even function. Then you add into even. The function is odd function. What about the odd function formula? It is 0. If it is even, maybe if the function is even, we are considering the 2 into integral 0 to infinity f of x dx. But the function is we get 0. Then your function is we get the odd. That's why we are considering 0. Similarly, I am getting variance also. We are solving that also by using this formula. Integral minus infinity to infinity. What about the variance formula? E minus x square. V of x equal to e minus x square minus v of x equal to e minus x square minus e of x whole square. In this continuous random variable, we are also using x minus mu integral minus infinity to infinity x minus mu whole square into f of x. Okay, x minus mu whole square f of x dx. Already we know. What about mu? Mu means 0. Already mean mu. That is 0. Integral minus infinity to infinity x minus mu whole square f of x dx. That means integral minus infinity to infinity x square f of x means c equal to 1 by 2. 1 by 2 into e power minus mod x dx. Here this total term is even function and x square is also even into even function. Then I am applying this one. That equal to 1 by 2 into integral 0 to infinity. I am using this one. Why? Because it is even function. Integral 2 into integral 0 to infinity f of x means here already 1 by 2 is completed e power minus x dx. That equal to 2 get cancel, remaining e power minus x by minus 1. Integral 0 to infinity. Upper limit is infinity, that is nothing but 0. Already minus is there, that is 0. Minus upper limit minus lower limit, that is 0, that is 1, that equal to 1. This variance is 2y c equal to 1 by 2 and that is formula is mistaken 1. Now next one. Same application I am using. Next, the integral 0 to pi, 0 to 4. Now I am applying integral 0 to 4 f of x dx, that is c equal to 1 by 2. Find the probability that the variate lies between 0 and 4. Integral 0 to 4, c value is 1 by 2. C value here is 1 by 2 and the e power minus mod x into dx. That means directly I am considering integral 0 to 4 1 by 2 e power minus x dx, that equal to 1 by 2 into e power minus mod x by e power minus x by minus 1, 0 to 4. That means 1 by 2 into e power minus 4 minus, already minus is there, minus e power minus 1, that means 1. We get finally the value is 0.4908. That is the final answer. How to find c means here applying by using density function, that equal to integral minus infinity to infinity f of x dx equal to 1. We get the c value and mean even function into odd function, that is odd function, we get 0. Variance even function into even function, we get even function, that is 1. And finally integral 0 to 4, I am substituting that also. Now the problem is completed. Next we can see the continuous random variables theorems. They are commonly we are applying the mean, variance, that one. We get the constants also. We can see that also. First one. The theorem first one. If x is a continuous variable and y equal to ax plus b, prove that e of y equal to a into e of x plus b. Here I am choosing y equal to ax plus b, that is equation number 1. Simply I am considering mean of e of y equal to integral minus infinity to infinity. What is the formula of mean? E of x equal to expectation or mean, anyone. E of x equal to integral minus infinity to infinity. X means here it is x into f of x dx. Here x is, we get x. Here, for example, we are considering y means integral minus infinity to infinity y into f of x dx. Here simply I am considering that only. Now what about y? Here y is, I am considering this total, I am considering ax plus b. Then it is ax plus b into f of x dx. Splitting into subparts. Integral minus infinity to infinity. A is ax plus b. A is a constant. X into f of x dx is the first part. Plus b into integral minus infinity to infinity f of x dx. Now we know the density function. This total part equal to 1. And this is nothing but mean, that is e of x. Expectation or mean, anyone we are considering. A into, this is e of x plus this is b into 1. We know the density function. Integral minus infinity to infinity f of x dx will be 1. Integral minus infinity to infinity f of x dx equal to 1. We know that one. I am substituting that one here. That is b into 1. E into a of x plus b. Then that equal to a into e of x plus b. Plus b. Plus b. Now first solution is completed. E of y equal to a into e of y equal to a into e of x plus b. Now the first part is completed. Next, variance of y equal to a square into v of x. We are solving in, this is in 2 or more methods. First of all, I am solving substitution method. Okay, first of all, v of y equal to a, this is the given condition. I am considering y equal to ax plus b is the first equation number 1. Similarly, I am applying both sides in expectation. E of y equal to e of ax plus b. Already in first statement we get this one is a into e of x plus b. I am applying that one, that is e of y. That is equation number 2. Now 1 minus 2, I am applying 1 minus 2. Equation 1 minus equation 2, that means y minus e of y. Y minus e of y. And in this part, that is in this part a into x minus e of x. Already here b, for example, applying both better, that equal to ax plus b minus a into e of x minus b plus b get cancelled. Remaining, what about remaining? Ax minus a into e of x. Simply I am coming with a. That means x minus e of x. That's why I am writing like here, like this. Now squaring on both sides means y minus e of y in LHS side. In RHS side, a into x minus e of x. Squaring on both sides with e square, with e, we get e of y minus, squaring on both sides and with the e. That means squaring and with respect to e. That means e minus, applying it better, e of y square equal to e of a square into x minus e of x whole square. Now here I am completed this one. Y minus, here one side we are considering, I am considering only this side, that is a square into integral minus infinity to infinity. A square remaining part is x minus e of x whole square, that is x square into f of x dx, e of x whole square, that is nothing but a mu square, that is a square into x square minus e of x, f of x dx can be written as e of x square. X into f of x can be written as e of x, and x square into f of x can be written as e of x square minus mu. Mu means it is e of x. Mu square means e of x whole square. This is nothing but variance. E of x square minus e of x whole square is nothing but variance, v of x. Then a square into v of x is satisfied. E of y is nothing but this part. Simply we are writing like this. Next one. Next to theorem 2. If x is a continuous variable and k is a constant, prove that v of x plus k equal to v of x. Now I am considering v of k plus x plus k. What is the formula of v of x? V of x equal to e of x square minus e of x whole square. I am considering x in just x replaced by x plus k. E of x plus k whole square, only this part square, and next e of x plus k whole square. Just I am applying e of x formula, that is integral minus infinity to infinity x plus k square into f of x dx minus integral minus infinity to infinity x plus k into f of x dx whole square. Again splitting into subparts, x plus k whole square, x square plus plus 2k plus 2xk into f of x dx. Now here it is x into f of x dx plus k into f of x dx whole square. I am splitting into subparts, x square f of x dx, k square f of x dx plus 2xk f of x dx minus x into f of x dx plus k into f of x dx whole square. Now that equal to integral minus infinity to infinity f of x dx equal to 1. Here I am substituting this part. This is e of x square. This is e of x square. We know earlier formula. This is e of x square. Now k square in this place k square into integral f of x means it is 1 plus 2k into x into f of x. Here only we get x into f of x. That is nothing but e of x minus x into f of x. Here starts with the bracket. Okay, x into f of x, that is e of x plus next k into f of x means 1 into whole square. Then total simplification we get v of x. Here k square, explaining that one also better. E of x square plus k square plus 2k e of x minus k e of x whole square plus k square plus 2k e of x. That means e of x square, e of x whole square is as it is. K square minus k square plus k square get cancelled. Here expanding that also better. E of x square plus k square plus 2k e of x minus e of x whole square minus k square minus 2k e of x minus 2k e of x. 2k e of x 2 plus 2k e of x get cancelled. Minus k square plus k square get cancelled. What about remaining e of x square minus e of x whole square? That is nothing but v of x. Now our condition is satisfied. V of x plus k equal to v of x. V of x plus k equal to v of x condition is satisfied. Now what about next one? V of kx equal to k square into v of x. That is v of kx equal to k square into v of x. Now again same formula. I am choosing that one. V of x equal to e of x square minus e of x whole square. That equal to, I am just substituting k x replaced by kx or xk. E of xk square minus e of xk whole square. Then applying our density formula, that equal to integral minus infinity to infinity xk square means x square k square f of x dx minus integral minus infinity to infinity whole brackets where starts with that one, and here it is xk into f of x dx whole square. Now here it is k square is a constant, integral minus infinity to infinity x square f of x dx is there, and minus k square. Here in total we get common with k square better. K square integral minus infinity to infinity x into f of x dx whole square. Then k square into x square into f of x dx we know, that is e of x square. Next k square into, here we know x into f of x dx is nothing but e of x. Okay, next x into f of x dx whole square. That's why e of x whole square. Common with k square, then that is e of x square minus e of x whole square. Then this is nothing but V of x, then k square into V of x. That is the final condition. This is also variance of the theorem, variance of the continuous random variable distribution problem, continuous random variable problem theorem. This is also satisfied. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.